Welcome to my YouTube channel, Physics Matters. Today I would like to discuss two important subjects at the same time. So we have the first one, which is called free fall. So we are talking about free falling objects in the gravitational field of the Earth. And the other one is called vertical throw or vertical shot. And we will later see that both of them are perfectly interconnected. And how this works we will see in a few minutes. So we will start with the easiest case that we can imagine, and this is the free fall. So we talk about, or before we can talk about, I would like to revise what we have discussed before, and this is the equation of motion. And in the general form we have given this as r of t, and we said it's a vector. It is 1/2 vector at square plus the velocity v0t plus an initial position r0. So now what does it mean if we actually talk about free falling objects? Free falling objects means that if we have here a coordinate system with 3 axes, x, y, and z, and we have here any object, which is in ideal case just a point mass. There, in this case, we have a vector pointing downwards, which is just an acceleration. And then, of course, this object is at a certain height. So from here, from our origin of the coordinate system until here, we can draw a distance which is h. And now the question is only what is the magnitude of this acceleration which is pointing downwards? And as we might know, every object is accelerating with the same magnitude downwards, and this is called gravity in the gravitational field of the Earth, very close to the surface of the Earth. And this is actually can be written as g, letter g, and in this case I call it minus g, because our acceleration points downwards in negative z direction. So now we can write minus g, and this is almost exactly 9.181 meter per square seconds. Or many times we can also just use the approximation, which is 10 meter per square seconds. And in most of the cases this is just enough, and for all the examples which we calculate I will use this value. Now we have actually everything what we need, because now we can directly write down the equation of motion for this free fall. So in this case we can write here, because we have only a movement in z direction, in negative z direction, we can write z of t, so we only need the third component of our r vector. And this is minus 1/2 minus g we have to insert t square plus v0t plus s0, but we don't have an initial speed, so this v0 is actually cancels out, and our s0 is our initial height h. So we can just simply write here z of t is equal to minus 1/2 g t square plus h. And this is our equation of motion for the free falling object. And because it is very important, I would like to highlight it. And now we have this equation of motion, so we can calculate a few things with this. For example, we could calculate the falling time of any object at a height h. So the falling time we can calculate by saying that our object starts at a height h and reaches ground level after some time. So the condition for our time t is given that z of t has to be equal to 0. And then we can just insert our equation minus 1/2 gt square plus h, and this is equal to 0. So now we have to solve this for t by first bringing h to the other side. So this then gives minus 1/2 gt square, which is equal to minus h. Yeah, then we can multiply both sides with -1 to get rid of the minus sign. And then we can also multiply with 2 and also divide by g. So at the end, what comes out is that on this side only t square remains, and on this side we will get 2 times the height, 2h divided by g. And now the only thing which we have to calculate is the square root of that. And if we do this, then our time t is given as plus minus square root of 2 times h divided by g. Yeah, this is our falling time. Let's call it tf. And yeah, we can only concentrate now actually on the positive time. The negative time would be completely unphysical. So I can write here actually once more, ignoring negative time because it is unphysical, and this at the end means that we get our final equation for the falling time just simply as t equals square root 2h over g. And again, this is a very important formula related to free falling objects, so I can highlight this again in red. Now we take a look at a certain example. So let's suppose we take a house with a roof, and somebody is standing here on this roof with a ball. Yeah, and this ball will just fall downwards because this person just releases this after some time. So then again, we have here our acceleration, in this case g, and our height should be given, just for easy calculations, as 10 meter. Now the question is, what is the falling time of that object? Yeah, so we can write here falling time tf given as 2h divided by g. This was the formula that we have derived previously, and now we have to only insert our values. So it would be 2 times 10 meter divided by 10 meter per square seconds, and then the square root. And now you can see why I usually like to use 10 meter per square second for the gravity, because then a lot of things cancels usually out. Yeah, so in this case we have 10 and 10. This cancels out, and what remains actually is 2. And for regarding the units, this meter cancels out, and s square remains, and the square root of s square is of course s. So our falling time is nothing else than square root of 2 seconds, and we know already that square root of 2 is approximately 1.4 seconds for the falling time of that object. This is in principle everything which we can discuss regarding free falling objects. So now we talk about the vertical throw, which is very similar, as I said before, but we can learn a few more things from that. So the main difference is that in case of the vertical throw, we have an initial speed v0. So our equation of motion becomes minus 1/2 gt square plus v0 t plus h. Yeah, this is the main difference, and again, this is very important. So let me highlight this once more. And yeah, what does it actually mean? So we have here our coordinate system again with 3 axes, x, y, and z. Again, in x and y direction, nothing happens. But in z direction, now we can draw here our object. And again, we have one acceleration pointing downwards, which is g. And we have, again, a height, let's suppose from here to here, which is given as h. And we have also another vector pointing upwards. And this is our initial speed, v0. So now again we can calculate the total time from that. which is always, from my point of view, the easiest thing that we can calculate. It's a little bit more tricky compared to what we have seen before for the free-falling objects, but it's also not so difficult to calculate it. So again, the total time can be calculated with the condition of z of t is equal to 0. And then again, we insert our equation of motion, minus 1/2 gt square plus v0t plus h, which is equal to 0. Yeah, and then we can see that it's not easy to solve it, because here we have t square, here we have a linear term with t, and here t does not exist at all, so we cannot just solve it directly for t. We have to use either some mathematical tricks or the so-called PQ formula, and in order to do this, we have to first multiply this with 2. Yes, and also divide by g, and we also have to multiply it with -1, so we can directly multiply it with -2. So when we do this, it actually turns out that this results in t square minus 2v0 divided by g times t minus 2h divided by g is equal to 0. So now what we have to do, I always recommend to check also the units here to make sure that our calculation is actually correct. So let us do this one time. Yeah, so the units of v0t divided by g, yeah, this is given as meter per seconds times seconds divided by meter per square seconds. And if we cancel out everything, what remains at the end is just simply second squared. Yeah, so we have here a t square. Here we have, which is second squared seconds. Yeah, here we have squared seconds. And now we also check the last term, which is in this case given as 2h divided by g. And this is, here the unit is meter per square seconds, and what remains is square seconds, so it means our equation is actually correct. So what we can do now, we can define our terms. So this whole part here would be our p, and this whole part here would be our q. So we can write down our PQ formula. So the general form is given as x squared plus px plus q, which is equal to 0. And then, as you know, the solution is given as x1, 2. We have two solutions because it's a quadratic equation, which is minus p half plus minus square root p half squared minus q. And if we apply this formula to our time equation, then in this case we can directly see that our total time would be v0 divided by g. This is our p half, so to say, plus minus square root of v0 divided by g squared plus 2h divided by g. This is our q. Yeah, and this is our total time. Yeah, the time of the objects which it needs to reach its highest position. Yeah, and then the time which it needs to fall down, the sum of both. And again, we only take the positive, the positive number into account because the negative one is unphysical. This is our time for the vertical throw, and due to this reason, I want to highlight it again. So now again, let's make an example to understand it better. So we have again our home, the same one which we have drawn before, and now again we have here a person standing on this with a ball in his hand, and again we have here our acceleration g, and we have here our height h, and we would have here another initial speed v0 pointing upwards, and this is actually what we have to define. So for this v0 we use again 10 meter per second, and for the height we use a value of 10 meter as we have always done before, and then we can directly calculate the time from that, the total time, which would be t tot given as, and then the formula we have to apply, so I can directly insert the values here. I don't have to write it down again. So our v0, here our v0 actually would be 10 meter per second. Our g is 10 meter per square seconds, and then it would be plus minus, and then we have here our 10 meter per seconds divided by 10 meter per square seconds squared plus 2 times 10 meter divided by 10 meter per square seconds. Yeah, and yeah, this is very simple. So when we take a look at our values, this part here is 1. This part here, actually this part only, this is given also as 1. Now, although it is squared, but it's still 1. And here, this 10 meter cancels out, and at the end, only 2 remains. So this whole part here is 2. So what we have now is, for the total time, 1 second plus square root 1 second plus 2 seconds, and this is a square root of 3, which is 1.7 approximately, plus this 1 second, and this as a result will be 2.7 seconds approximately. So the whole time until the object reaches its highest position and also until it falls down again is 2.7 seconds, and it must be higher, of course, than only the time of this free falling object. And in contrast to free falling objects, we can also calculate another important quantity here in this case, and this is the maximum height of our object that moves upwards first. And in this case, so before it falls down again. So in this case, we can take again our equation of motion, minus 1/2 gt square plus v0t plus h. And now what we have to do first, we have to calculate the time that the object needs to reach its maximum z position. So what we do, we calculate, in order to calculate the time, is by simply calculate the derivative of z with respect to t, as we also learned it in mathematics. So this in this case would be 0 prime of t equal to 0, the derivative with respect to t. And this, of course, here the derivative of this would be minus gt plus, and then here we have to write v0, and this has to be equal to 0. This is just a simple way how we can calculate the maximum. And then in this case we can solve this for t by simply subtracting v0 and then divide by minus g. And this then gives, for the maximum time, let's call it t max, just simply v0 divided by g. So after that time, it's also a very important formula, so we can highlight this. After that time, v0 divided by g, the object reaches its maximum. And now if we want to calculate the maximum height, then we have to insert this into our z of t. We have to just insert it back into our equation of motion. And then we get our maximum height, let's call it z max, which is then given as 1/2 v0 squared divided by g plus v0 squared divided by g plus h. Here we also need minus, so minus 1/2 v0 squared divided by g plus v0 squared divided by g is simply given as 1/2 v0 squared divided by g plus h. Yeah? And this is our equation for calculating the maximum height. Yeah, so just to highlight it, let me briefly write it down once more. 1/2 v0 squared divided by g plus h, and now I can draw again a red rectangle around that. So let's calculate the last example which highlights that. So I will not draw a picture again, but we know already that our v0 is 10 meter per second. Our initial speed and our height h should be given as 10 meter. So we can calculate the maximum height as z max. And then we use this formula that we have stated before, which was v0 squared divided by 2g plus h, and then we have to insert our values, which is 10 meter per second squared divided by 2 times 10 meter per square seconds, plus 10 meter, and again many things cancel out. Yeah, so here only the value 10 remains. 10 divided by 2 is 5, so we can actually write here 5 meter plus, and here only 10 meter remains, and the units are matching very well. So at the end, this leads to a total height of 15 meter. Yeah, so the object is already starting at a height h equal to 10 meter, and then it travels more 5 meter upwards, and then later it falls down. And at the position from where it started, it will reach also the same speed again with which it started, but this time into the other direction. This is also the reason why, for example, it's not good to shoot a bullet upwards into the sky, because when it falls down, it has almost the same speed as it had when it left the weapon. So in this case, it's really dangerous. Okay. This is everything what I want to explain you in this video. I hope that you enjoyed it as usual. And yeah, hopefully see you very soon for a new physics lecture. Thank you very much for watching this video. If you like the content and want to see more of it, please like and subscribe. And in addition, any kind of support is always appreciated.